Hi, today I'm going to show you how to use Parallel AI platform to build an optimization pipeline, simulate the process and deploy it. So let's start by creating a new graph, a new model here. And let's say that we want to model or we want to simulate a vehicle routing problem. So we can select the toolbox, routing, and we can drag and drop the VRP block, vehicle routing problem here. So normally we would add locations and we would add vehicles here. So we can do that and we can double click on location block. And when we do that, we open the location window where we can create some groups. For example, if you are modeling multiple depot vehicle routing problem, you can create different groups for different depots. For example, let's create group 1 and location in Boston, let's say. We can load the group and we're gonna see here the map of Boston, and we can pick up some delivery locations like this. We can also create another group, for example, for New York, like here, and we can load the group for New York, right? So you see a similar thing. We can select the destinations, the locations here. Similarly, we can do the same for vehicles. We can set up a list of groups and a list of vehicles here. But for this example, I'm going to avoid using the user interface here, the graphical user interface, and we're going to do the same thing with a JSON input. Why JSON? Because you probably want to deploy this and you want to stream information to the VRP block in form of JSON files, JSON inputs. So let's just delete these blocks here and do the same with JSON. To do that, we can select the JSON block from data import toolbox. We can select another one for the vehicles. So this one is going to be for locations. This one is going to be used for specifying vehicles. So let's try to connect these blocks here to form a pipeline. And we use the first one to set up the location. So you see that when I double click on it, I open the JSON window where I can write JSON code or I can load it up. I already created here some JSON files for our locations and drivers. So let's copy and paste directly this JSON input here. And you see what do I do here? I specify basically groups, like in the interface, the user interface, and the name of the group, right? Boston group, for example. And here I have the addresses of the locations where we want to send our vehicles to, right? And the coordinates. We can specify for each location a demand that we want to satisfy when sending the vehicles. So this is the location JSON input, and you can think about streaming this from your computer or from your system when it is deployed to the Parallel AI backend, and it's gonna process this input here. Similarly, we can do the same for the vehicles. So I double click on it, and I can copy and paste now the drivers. And you see for the drivers here, I have the name of the driver, Mario, the capacity of the vehicle, 15, and the cost for the vehicle, right? 3. Let's say it's got $3 or 3 cents per meter, right? And this is the location. The location represents the depot, right? Where the drivers start delivering their items, right? The depot, this is the address. Perfect. So now we have our model. And when we click on VRP block, we open up a window like this. We can set up some parameters like time limit and solution limit. And now we have our model and we can simulate. We click on the run button. This is going to call the backend engine and it's going to simulate the process and solve the vehicle routing problem. And you see that now we have our solution. We have Mario, John, and Luigi, our drivers, total cost, and the distance in meters, right? So we can click on one single driver and you see the route where it's going to, right? So this is our solution for the vehicle routing problem, but you probably want to stream this to an endpoint, right? You want to probably stream it out to a computer or somewhere to further utilize this, right? So for example, you can stream this solution to an app, right? Or to the driver's phone. Well, you can do that by allowing the vehicle routing problem to send out an output. So you check the output. If you see here, you check the output checkbox and an output socket appears. So how do we do now? What do we do with the output socket? Well, now we can simply go into the data imports toolbox and drag and drop an endpoint block, right? So we can connect this to an endpoint And this is going to basically represent our endpoint where we want to stream to. So we double click on it and we open an endpoint window. You see, this is the port that we want to use, maybe 64,000, and the channel name, right? Output. Perfect. So this means that when we are going to deploy this system here, this is going to create basically a backend service, like a service on the cloud, ready to receive some inputs and to run the vehicle routing problem model and stream out to an endpoint that we just specified, right? Now, how do we stream the inputs? Well, we can stream those with a data stream block here. So instead of basically using a JSON constant file, a JSON constant input, we can replace this with a data stream block like this. And when you use the data stream, you can specify the data type. In our case, it will be a string, and the data template. This is basically what is going to be used when we simulate, right? So, for example, if you want to simulate this model here without deploying, well, you can still use a data stream even if you don't have data coming in input to the system, but you can use this template here, the port and the channel name, right? So this is how you stream data. Now, of course, this is you use the VRP block and it's going to be used as a baseline. But what you want to do probably is to write your own algorithms or to use your own algorithms for a vehicle routing problem, right? Or, for example, you want to use a pipeline. You want to create a pipeline where you want to chain up different AI algorithms, right? For example, you want to use evolutionary algorithms like genetic algorithms, and you want to use local search to create, for example, a process where you first find the depot in a multi-depot vehicle routing problem, and then you can change the results here to the VRP, or you want simply to use your own VRP models, right? So let's say that, for example, you have a solution that is solved with a mixed integer programming. Well, you can do that by drag and dropping here a PLL.AI block, which is used to write mixed integer programming models, or you can simply upload an MPS model. But let's use an PLL.AI block. When you double click on it, you are able to write your mixed integer programming model in Python like this, and you see you can choose the output type here, in this case JSON. You can choose also the solver type that you want to run your model on, so CBC, C++, Gurobi, SCIP. You can choose the instance type where you want this problem to run on. In this case, we support AWS instances, so M4, M4X large, M5, and then you can choose also the level of parallelism, right? So you can say that you want to have a multi-threaded solver, or you want to have a distributed solver, right? So in this case, we just select none. So you write your own model here, and well, then probably you want to stream some data to this mixed integer programming model and stream out the results that goes into the VRP, for example. So how do you do that? Again, you check the input checkbox, and you see that an input socket appears here. So in this case, you would do this, right? You would basically connect the data stream to the PLL.AI block here. You can disconnect this, and you can connect now basically the PLL.AI model that you write to the VRP. So now you see that you're going to stream your data to the data stream block, to the port that you specify. You run the mixed integer programming or local search or large neighborhood search or whatever heuristic or algorithm you want here. This is going to trigger the computation of the VRP model, and you're going to stream out the results to an endpoint that you specify. Perfect. So what if you want to write completely your own function, right? You want to run scale basically your own Python function. Well, you can do that by drag and dropping a function block, and we can do that, for example, by let's create a new model here, and I'm going to show you how to do that. So again, we drag and drop a data stream block like here, right? And then we're gonna drag and drop a function block, and finally we can either see the results on the monitor or we can stream to an endpoint. Let's say endpoint in this case. So we connect this to create a pipeline. an optimization pipeline, exactly. And this now you see that is basically mimicking what we have here, right? You have a data stream. This is going to be represented by our function block, and this is the endpoint, right? So data stream, you have data stream here. Then we have all these three blocks here, 1, 2, and 3, represented by this function. And then we have the endpoint here, right? Endpoint here. So let's work on this now. What do we do? Well, again, let's specify the data stream, and we say that we're going to stream a list of integers, for example. We can use this data template here, and to a port that we say 5001, and the channel, the name of the channel input, a buffer size of 1000 elements, right? Okay, perfect. Now we open up the function block, and when you open up, you see basically you have an editor for writing Python code. This is the name of the function, my function. You receive, as we said, a list of integers. And in this, for this example, let's say that we return the first element of the list like this. Outputs is an integer as well. And we can also specify a path to a folder where you can, import other Python files, basically. So this is our function for now. You can think about replacing this function with your own algorithms, right? Perfect. And now we have the endpoint here, and we can stream this results to an endpoint we specify. Let's say that in this case we stream to my localhost 127.0.0.1. In general, you will have an IP here, and this is going to stream to our parallel AI backend cloud system. So let's say that we use the same port 5001, and the channel name is going to be output. So you see that we're going to stream to this IP. You're going to stream solely to port 5001 and channel input, and you're going to receive the results to port 5001 and channel output, right? Perfect. So now we could simulate this by using, for example, the result to see the results on a monitor block. When you drag and drop a monitor block here, you can connect this to the monitor, and you're going to see the results appearing here. But for now, we are basically just going to trust this is working, and we're going to deploy this system here. So let's deploy it. To do that, we can click on deploy block. Here we can select again the basic instance types that you want to deploy this system to, and we can click on deploy like this. Now it's going to analyze, and it's going to deploy this on production, right? So now you have basically a backend service that is start listening to the port that we specified, and it's going to run whenever it receives an input here. It's going to run a function and stream the results to an endpoint here. So now we can verify that by using basically opening up this port here, these terminals here, and here I'm going to use basically the car command. We know about this. Car is gonna basically send a post request to this IP, to this port here, 5001 and channel input, as we specified in the data stream. We say that our input type is going to be JSON here, and we specify a list like this here. Let's say that we put a random number 34098. When we are going to stream this is going to go to the data stream block. It's going to trigger the function, and you're going to send out to the endpoint here. So let's send it, and now let's go to get the results from the port 5001 channel output, and we should see the first element of the list, as we said, as we specified in this function, remember? So let's check again. This is return the first element, and when we get this, you see we have the first element, and you can go on with the streaming data. You can think about streaming like thousands of inputs, right, per second, and receive here the results on the other hand, right? You see 2341, 2341. Perfect. And once you do this, we show how to run a simple function here, but you can do the same with basically all the models that you have. So you see, you can chain here different blocks and form, create a pipeline, optimization pipeline, and you can stream data in real time and receive data to an endpoint that is specified in real time. And with that being said, I think that's all. And thanks for watching.